Hi, welcome to Maths with Shai MA. I am Shai MA. Please like, share, and subscribe. Let's get to today's lesson. Today we are looking at summing a geometric series. Summing a geometric All right, so let's take for an example a geometric series 2, 4, 8, etc. and etc. So this is a geometric series. It's a geometric series. Excuse me. So it's 2, 4, 8. So we already know that it's a geometric series because it has a common ratio. If you check, 4 divided by 2 is 2, 8 divided by 4 is 2. So it has a common ratio, which is 4 over 2 times 2, which is the same as 8 over 4 times 2 over term 1 over term 3 over term 2. So the answer is 2. So it has a common ratio of 2. So it is a geometric series. Now we are going to add terms of a geometric series. Now, but before we add the terms of a geometric series, let us find the formula for adding the terms of a geometric series, because this is very important. Let's take a geometric series. So we want to add, so sum n, we know that the first term is a, the second term is ar, the third term is ar squared, like that, like that, like that. So we are going to add the terms. The last term of a geometric series is ar exponent n minus 1. Now a term before the last, obviously it will be ar exponent n minus 2. So we want to add the terms of a geometric series. Now we're saying this is a series because we are adding. If it's just the commas there, it's a sequence. So we are now going to multiply the sum n with r. So in other words, we will have r multiplied by sum n. So r multiplied by sum n, in other words, we take every term, we multiply it by r. Now if we say r multiplied by a, the answer is ar. So in other words, let's just put it below the ar, and then we have ar plus, so we multiply the r with the ar, and then we have ar squared, like that, like that. So in other words, the term before that, it will give us ar to the power n minus 2. When you multiply ar exponent n minus 2, we will have, let's do it separately so that we can be able to see it. Ar exponent n minus 2 multiplied by r. So we will have a, then the bases are the same. So we have r to the power n minus 2 plus 1. We know that there's a 1 there. So we will have ar exponent n minus 1. So we can be able to see that if we multiply by this one here, it gives us this one, ar exponent n minus 1. So, but we are not done. We have to multiply this, and it will give us ar exponent n, because if we look at it, it's a multiplied by a, not a, but r multiplied by ar exponent n minus 1. So that is what we are doing there. So we have this is going to be a multiplied by r exponent, we have the n minus 1 plus this one here, so we have a r exponent n. So we are able to see that when we multiply this, we get ar exponent n. So we are going to look at this. We are going to, now we can subtract. We are subtracting, if this is term number 1 and this is term number 2, we are taking term number 2 and subtracting term number 1. So we will have r Sn minus Sn equals to, so here because there is nothing, we can have 0 minus a is just minus a, and all these other ones will subtract each other up until the last one here. So it's ar exponent n, it's subtracting nothing, so it will just be plus ar exponent n. So we have r Sn minus Sn equals to, if we rewrite this one, we will have a r exponent n minus a. Then we can take out a common factor. Let's start here. The common factor in this is Sn, and then we take it out, and then we have r minus 1, which is, we take out a common factor here, which is a into r exponent n minus 1, and then we divide both sides by r minus 1. We divide by r minus 1, so this cancel out, so the sum n will give us a into r exponent n minus 1 all over r minus 1. So this is how we find sum to n terms. Right, now I want us to look at, if we take term 1 and subtract term 2. So we will have sum n minus r sum n. So we are having sum n, so this is another way of doing it, sum n minus r sum n. So this will give us sum n. In other words, we will have a minus, this a is subtracting nothing here, so the answer will just be a, and then we will have minus, so all other terms will subtract each other. So here it's like 0 minus ar exponent n, this ar exponent n there, so the answer will be a minus ar exponent n. So we do the same, we take out this Sn as a common factor. So if we take out Sn there, we will get a 1, and then minus, here we will be left with r. So this is, we take a out as a common factor, so we have a into 1 minus r exponent n. So now we can divide both sides by 1 minus r, divide both sides by 1 minus r, and we get our Sn to be a into 1 minus r exponent n over 1 minus r. So we can use any of these two formulas. We can use this one here or that one there to calculate the sum to n terms. Any of them will do. So, but in most cases, for calculations to be easier, we prefer to use the first one if the value of r is actually more than 1. If r is more than 1, we prefer to use this first formula. And we prefer to use this one if r is actually less than 1. Right, so remember, r will never be 1. So if it's 1, we won't have a formula because we will have a division by 1. So if r is more than 1, we can use that one. If r is less than 1, we can use this one. So we need to decide there which one we want to use given which condition. But in any other case, we can use any of the two formulas. Regardless of the situation, we will get the answer that we need. So that is how we calculate the sum to n terms of a geometric series. So we are going to, for example, go back to our series, the one that we started with. So 2, 4, 8. So we are taking the 2, 4, 8 as an example. 2 plus 4 plus 8. So we are going to add, let's say we want to add 10 terms. So we want sum 10. Right, now we have already seen that the A is a 2, we can see it, that's the first term. And the R, it's also a 2, we have already done it, 4 divided by 2 or 8 divided by 4. So in this case, A is 2, R is also 2. So we can use any of the formulas above. So, but then we said we will prefer to use A into R exponent n minus 1 over R minus 1 because the R is more than 1. But even if we use the other one, it will still give us the answer that we need. So we are calculating sum to 10 terms. So we are going to substitute A is a 2, R is also a 2, and is 10 because we are calculating sum 10, and then we divide by 2 minus 1. So we can use a calculator. So we are going to use this scientific calculator here, the Casio. So we will press it as it is. So for the division sign, we'll have this A over B right here. And then we have a 2, open bracket, we have 2, and excuse me, sorry. We said we have 2, open bracket, we have 2 to the power, so to the power is x exponent y there. So it's 2 to the power 10, and then we go this side so that we can have a minus 1. Then we close the bracket, and then we come down, so we have the 2 minus 1. So as we can see here, the answer is 2046. So that is how we use the Casio calculator. So we can use it to calculate the sum. So as I said, you can even use the other formula there to get the sum, the same sum. So you can use that other formula. So let us look at this other series. We are looking at the series 16 plus 8 plus 4 plus. So I want us to discover something here. Now we are going to calculate the sum of the following terms. We are calculating, I want us to calculate sum to 5 terms, and then sum maybe to 10 terms, sum to 20 terms, and then sum to 50 terms, and then maybe sum to, let's say, 1,000 terms. So I just want us to look at this and see what is really happening. Now, looking at this series, so we can all see that the A value is 16, and then the common ratio, the R, it's 8 over 16, which is the same as 4 over 8. So we can see that the answer is half. Right, so we are now going to calculate the sum. Now, let's start with sum. Okay, the formula for sum n, we said we'll prefer, because the r is half, which is less than 1, we prefer the formula a into 1 minus r exponent n all over 1 minus r. Right, so we are going to calculate sum 5, meaning where we see n, we will put 5. So a is 16 into 1 minus r is half. Okay, so this is to the power of 5. Okay, it's best to use the big bracket. So this is over 1 minus r, which is half. So we go back to our calculator. Right, so let's do this one. We have 16 into 1 minus, okay, so it's a over b, so it's the r is 1 over the r is 1 over 2 right, so we should close the small bracket and then divide by 1 minus the 1 over 2. So okay, so that is to the power 5, excuse me, to the power of 5. We need to do this, so this is to the power of 5. So you can see the answer is 31. So the answer is 31. So sum 5 is 31. Let's look at sum 10. Sum 10. So for sum 10, we are just going to substitute the 5 with the 10 on our calculator. We don't have to go far. We can just press delete there and we put a 10. And then we are getting 31,96875. So let's just write it as complete like that. Now we want sum 20. Sum 20, so we'll just substitute that 10 with a 20. Right, so if you can see, sum 20 is giving us 31,9999. Okay, and there's a 6 and a 9. So if we can just write so many of them there. Okay, now let's go to sum 50. So we can just delete the 20 and put a 50. Wow, so sum 50 is exactly 32, right? Let's go to sum 100. Let's take sum 100. Sum 100. So we are just going to substitute the 50 with the 100. So sum 100, it's also giving us 32. Now, if we look at this, everything is taking us back or is getting closer to a certain number. In this case, is 32. So sum 31 was 31,96, so which is closer. Sum 5 was 31. Sum 10 was 31,96, which is closer to 32. Sum 20 was 31,999, which is closer to 32. And then some 50 is exactly 32. Some 100 is exactly 32. Okay, let's look at some 1000 to prove our point here. So now we are going to look at what happens when we add 1000 terms. So we are just going to put 1000 there. So can you see it's also giving us 32. Now, this type of a series whereby the sum goes closer to a particular number, we say it's a convergent series. Convergent series. So we are saying it's a convergent series because the more we add sums, the more we put a number of terms that we are adding, the closer we are converging to a particular number. So it's a convergent series. Now, how do we know that this is a convergent series? We know this series is going to converge if the common ratio, the R, is going to be a number between -1. The R is going to be a number between -1 and 1, but not 0. So we need to understand R is not 0. So as long as the number is between the ratio is between -1 and 1, then the series is going to converge. An example is the one that we had there. So remember our R was 1/2. So 1/2 is a number between -1 and 1. So if it is like that, then we have a convergent series. So the series now converges. So we are going to look at an example of a question where they ask us about a convergent series. So for example, if we have a sequence, let's say it's 3x minus 5, and then let's say it's a series 3x minus 5, and then 3x minus 5 squared, and then 3x minus 5 to the power 3 plus plus. Now the question is, for which value or values of x will the series converge? For which values of x will the series converge? Now, we know that it will converge if R is between -1 and 1. That's how we must always answer our questions. That's where we should start. For it to converge, the R must be between -1 and 1. So in other words, we have to calculate the R. So in this case, already it's a geometric series. So we will take the R. We know that we can just take term 2, which is 3x minus 5 squared, and then we divide it by term 1, which is 3x minus 5. So the 3x minus 5 will cancel one of the 3x minus 5, then we are left with 3x minus 5. So that is R. So we are going to put the R in between there. So the R is 3x minus 5 and then 1. So the question is, get the value of x, because they're saying for which values of x. So we can now work this out. So when we take the 5 to the other side, it's going to be -1 plus 5, which will actually give us a 4. And then when we take it to the other side, it will be 1 plus 5, which will give us a 6. So dividing through by 3, so we will have 4 over 3 less than x less than 6 divided by 3, it's a 2. So in other words, for this one, the answer is x is something between 4 over 3 and 2. So if x is between 4 over 3 and 2, this sequence or this series is going to converge. Right, so that is one example. Now another example, let's take another example. So if the series converges, meaning if the value of r is between -1 and 1, then we can be able to calculate the sum to infinite number of terms. We have seen it that, okay, in our series 16, 8, 4 that we have been looking at, we calculated sum 5, it gave us 31. We calculated sum 10, it gave us 31,99 something. So if you check, as we continue adding the terms, we also realized that when we calculated sum 50, we got 32. And also sum 100, it gave us 32. Or even if we calculate sum 1000, we'll still get 32. So in other words, therefore, from this we can conclude that many terms, infinite number of terms, let's use infinite, let's use the symbol for infinite. So some infinity for this series will give us 32. Now we need to look at our sum formula and check how do we get sum to infinity. So we remember that sum to n terms, it's a into 1 minus r exponent n all over 1 minus r. So to get to sum to infinity, we are going to take, we will actually remove this part here, and we are left with a over 1 minus r. So that will give us our sum to infinity. Right, so this is our formula for sum to infinity. Now let's see whether it will work on this one. Is it going to give us 32 as we have concluded? So sum infinity is going to be a, the first term, which we said is 16. So it's 16 divided by 1 minus r is half. So we actually have 16 divided by 1 minus half is half. So 16 divided by half is 32. So you can see it gives us that 32 right away. So now we are able to add sum to infinite number of terms. So we can calculate sum to infinite number of terms if the series converges, only if we have a convergent series. Right, now we are going to take few examples. Let's take an example of 2022. We are going to look at that example. November 2022. Now, let's look at this example for November 2022 NCS grade 12 exam. Now, let's look at this one. It was question 2. Looking at it there. Right, they're saying here the first term of a geometric series is 14 and the sixth term is 448. Now, calculate the constant ratio, that is R. So we are going to work this one out. So it's 2.1.1. Now we know that, okay, they're saying the first term, meaning term number 1, which is represented by A. So we are given that A is 14. And the sixth term, meaning term number 6, we know that term number 6 of a geometric sequence is AR exponent 5. So we are given that term number 6 is 448. So we will just substitute the A there on the term number 6. So A is 14. So it's 14R exponent 5. It's 448. Divide both sides by 14. So you can simply do this on your calculator. 448 divided by 14 is 32. All right. So R exponent 5, we know that 32. Let's show you again. On the calculator, let's see, you press 32 and then you press equals to, and then you press shift and you press fact. So you are able to see that 32 is 2 to the power 5. Right, so we have that. So it's 2 to the power 5. That's our 32. Right, so it means now the bases are the same, or the exponents are the same. It means the bases are the same. So giving us the value of R to be 2. Right, so that was 2.1.1. We just substituted there to get the value of R. Right, so it was 2 marks. Now let's look at 2.1.2. Determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. Right, so we need to analyze this question here carefully. So we have the first 6 terms, term 1, term 2, 3, 4, 5, and 6. Now, they are saying here, we have to determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. So we have to add certain number of terms, and when we add them, we add to the first 6. This is the first 6, and then we don't know how many we are going to add this side, how many terms we are going to add this side, but after doing the adding, we must get 114,674. So we need to understand the question. We have the first 6 terms, and we add a certain number of terms, and then we get this 114,674. Right, so we can do this in 2 ways. We can first get the sum of the first 6. Let's do that. Let's get sum 6. we know that the A is, the first term is 14. So the A is 14. And then the common ratio, we can see it there, it's a 2. So if we calculate sum 6, we know that sum n is A into R exponent n minus 1 over R minus 1. Excuse me, we are adding sum 6. So sum 6 will be A, which is 14, into R to the power 4, the power 6, and it's 6, minus 1. So remember, R is a 2, so it's 2 to the power 6. Let's delete the mess here. So it's 2 to the power of 6 minus 1 all over 2 minus 1. Right, so we can use our calculator. We can use our calculator to get the answer there. So we have 14 into 2 to the power of 6 exponent 6. Then we press the arrow there. Then we have minus 1. Close the bracket. Divide by 2 minus 1 is just 1. So we can just take that as an answer. So it's 882. It's 882. So the answer is, so sum 6 is 882. Now we got sum to 6 terms. We got a sum to 6 terms there, so which is 882. Now what is going to happen is the remaining sums, when we add them and we take away this first 6, which was 882, we must know how many terms it must give us that. So in other words, we are going to look for the first term here, and then we know that the R is 2. So we need to take this answer here and subtract that for the first 6 terms. So let's do that. So if we take 114 minus 672, if we take 114672 and we subtract 882, 11464, and we subtract 882, so it means the terms that remain here will give us 113792. So the sum of the remaining, the sum of the remaining terms, will be this 113792. All right, now let's look at the remaining terms. So we know that term number 1, let's get term number 1. We know that term number 6 here, we were given, remember, we were given that the 6th term is 448. The 6th term is 448. So this 448 is term that is here, is 448, term number 6. So 448. So if we want term number 1 here, we just know that to get to the next term, we just multiply by the common ratio. So we just take the 448 and multiply it by 2, so that we know the first term of this series starting here. So 448 times 2 is 896. So we are going to take this as our first term, 896, and then we are going to check how many terms are there. So term number 1, which is A, is 896. A is 896, and then R is 2, and the total is 113792. Now let's apply our formula there. So we know that the sum to n terms is A into R exponent n minus 1 all over R minus 1. So this sum is going to give us 113792. All right, so let's substitute. A, which is the first term of that remaining sequence, is 896. And then R is a 2. The n is what we are looking for, minus 1 over R is 2 minus 1. So this is giving us 113792. All right, so it means we are going to divide both sides by 896. So this side, when we divide by 896, we will be left with 2 to the power n minus 1 equals to the 113792. We will divide it by 896. So we have divided both sides. So 113792, if we divide it by 896, you can use your calculator to do that. So you will get 127. So take the 1 to the other side. So 2 exponent n is 128. Right, so you can use your logs here, or you can go straight to n is 2 to the power of 13. Excuse me. 2 to the power of 7. Right, so it means therefore that the value of n is 7. Right, this was a complicated way of doing it. Okay, another way of doing this problem is to take all the terms, including the first 6 terms. So in other words, if we look at these terms, the question says, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114674. Right, in this case, we just take the terms as they are. Now, we know that the first term is 14. So we take A as 14. So we say that A is 14. A equals to 14. We know that the common ratio is 2. So R is 2. So we calculate sum n. So sum n is A into R exponent n minus 1 all over R minus 1. So what we're going to do is we are going to take this A as 14, R as 2, and then we equate it to the total that they gave us, the 114,674. So that will be an easier and a quicker way. So let's look at it. So the sum is 114,674. So this equals to our A is 14. R, we know it's 2 to the power n minus 1 all over 2 minus 1. So we are going to take the 114,674 and divide it by 14. 114,674, we divide it by 14. And if we do that with our calculator, we get 8,191. So the 2 minus 1 is just 1. So we have divided this by the 14. So we got 8,191. So in other words, 2 to the power n minus 1 equals to 8,191. So if we take this one to the other side, we will have 2 exponent n equals to 8,192. Right? We can here we can apply the logs, or we can write this in exponential form. So this is 2 exponent 13. So in other words, the n is 13. But this 13 includes the first 3 or the first 6 terms. So in other words, the other terms, the number of terms that are added, we will just take the 13 and subtract the first 6 and we'll get 7. So this is an easier and a faster way of doing it. Okay, so now let's go to the next question. Number 2.2. Let's look at this question. So we 2.1.3 rather. If the first term of another series is 448, so the first term, meaning A, is 448, and the sixth term is 14. A is 448, and term number 6 is 14. Calculate the sum to infinity of the series. So A is 448, and term number 6 is 14. So we are asked to calculate sum infinity. Now we know that sum to infinity, the formula for sum to infinity, it's A over 1 minus R. So we have A to be 448, and then it's 1 minus R. So we need the value of R. Right, so let's get the value of R first. So if A is 448 and term number 6 is 14, so we know that term number 6 is AR exponent 5, which is 14. And then if A is 448, R to the power 5 is 14. We divide by 14 both sides, so R to the power 5 will be 14 over 448, which actually gives us 14 into 14 goes once, and into 448 it actually goes 32 times. So this is 1 over 32. Right, so we will have R to the power 5 equals to 1 over 32 is the same as 2 to the power 5. So we can write this as 1 over 2 to the power 5, giving us R to be 1 over 2. Now we have the common ratio. We can substitute on our formula. So sum to infinity will be 448 over 1 minus 1 over 2. And then we just get our answer. You can press your calculator and get that answer there. So it's an easy one. You can just do it using your calculator. So 448 divided by half, it's actually 896. So that is the question that we had. So the sum to infinity is 896. So it's a different question altogether. Right, let us look at question 2.2. Now, if we have a sigma notation here, we have 1 over 3p plus 1 over 6. It's starting from 0. So when we add all this, we are getting 20 and 1 over 6. So determine the value of k. Now, when we have a sigma notation, what we must always do is to expand. The first thing that we must do with a sigma notation is to expand. Now, if we expand this, remember we start where they say we have to start. They said the first term must start, we start with a 0. So we substitute p with a 0. So if we put 0 on p for the first term, we will have 1 over 3 times 0, which is 0, plus 1 over 6, which gives us 1 over 6. That's the first term. Now we put a p to be 1 because we are going up. So we have 1 over 3 times 1 plus 1 over 6. So this will give us 1 over 2. You can do that using your calculator. And now you put a 2. When you put a 2, you have 1 over 3 times 2 plus 1 over 6. And this will give you 5 over 6. Right, so as we add all these terms up to k terms, we will get 20 and 1 over 6 as indicated there. Now, it means we are going to do the summation here. So first of all, we must know what type of a sequence do we have. Remember, we can have an arithmetic sequence, we can have a geometric sequence. So by just looking at it, you might not know what type of a sequence it is. So you have to calculate the value of r. If you get a common difference, then it is geometric. But if not, you calculate the value of d. If you get the common difference, then it is arithmetic. Common ratio, geometric. Common difference, arithmetic. So let's start with the common ratio. So if we try to take term 2, which is 1 over 2, and we divide it with 1 over 6, if you use your calculator from there, 1 divided by 2, and then we divide it by 1 over 6. So this one, it's going to give us, you can see it's 1 over 2 is the same as multiplying by 6. So this is giving us a 3. And if you look at term 3 divided by term 2, we will be having 5 over 6 divided by 1 over 2. And clearly you're able to see that this, it's actually giving us, if you see, it's 5 over 3. And 5 over 3 and 3 are not the same. So this is not a geometric series because we don't get a common ratio. 5 over 3, this side we get a 3. So let's try arithmetic. So with arithmetic, we are going to take, let's try to get d, which is term 2, which is 1 over 2. And then we subtract term 1, which is 1 over 6. Right, so 1 over 2 minus 1 over 6 will give us 1 over 3. And then let's see whether the same thing happens. 5 over 6 minus 1 over 2. And it's definitely giving us 1 over 3. You can use your calculator to get that. So we realize that this is an arithmetic series with the common difference of 1 over 3. Therefore, we are going to use the arithmetic equation for the sum to n terms. Right, so let's remind each other. Sum n is n over 2 into 2a plus n minus 1d. Right, so we are given the sum to n, let's substitute, is 20 and 1 over 6. We prefer that we write this 20 and 1 over 6 as in proper fraction, so it's 6 times 20 plus 1, which is 121 over 6. So it is better to write it as 121 over 6. So this n is what we are actually looking for. So we leave it that way. So we have a 2a is the first term. So let's remind ourselves, first term is 1 over 6 as we are expanding. So it's 2 into 1 over 6 plus the n minus 1. The common difference, we worked it out to be 1 over 3. Right, so we can work this one out. So we have 121 over 6 equals to, this is n over 2. So we multiply this, we get 1 over 3. Remove the bracket here. 1 over 3 times n is 1 over 3n. 1 over 3 times minus 1 is 1 over 3 minus 1 over 3. Now you can see 1 over 3 subtract 1 over 3. So we are left with 1 over 3n inside the bracket. So we can work it out and have 121 over 6 equals to, we take the n over 2 and we multiply by 1 over 3n. So it will give us 1 over 6n squared. Right, so multiplying by 6 both sides, we have n squared is 121. Right, and then we find the square root both sides, so n is 11. So it means that this k that they said we must find, because they said we must calculate the value of k, so it means k is 11 because n is k. We need to know that n equals to k. So that's that. Thank you very much. Please don't forget to like and subscribe. Thank you.